Okay, so in this video, we're going to be talking about expected allowance. So Dale gets $15 a week for allowance. He also loves to play basketball. Dale wants to convince his father, Mr. Doback, to try something new with his allowance based on his basket shooting talent, hoping it will increase what he receives. Dale suggests that instead of getting $15, he attempts shooting baskets each week for his allowance. Now, if he misses the baskets, he only gets $5. If he makes or succeeds with the first basket, he gets $15 and a chance to make another basket for an additional $10. Now it says Dale can make a basket 40% of the time. So to help Dale's father decide whether to use the new allowance plan, find the probability of Dale making 0 baskets, 1 basket, and 2 baskets, and justify your answer, your reasoning with an appropriate model. So what we're going to do is we're going to create a tree diagram, okay? So in the very beginning, we have 2 possible outcomes. We can have a make or we can have a miss, right? So on the first shot, he can make it, or he can, I'm going to use an H to represent hit. So he can make it or he can miss it, right? He can make it or hit it. So this is the first basket. He can hit the basket or he can miss it. Since he makes a basket 40% of the time, for H, we're going to put 0.4. So that means the remainder, which is 0.6, is on miss. Now, if he misses the basket, then it just ends here, okay? It just stops. He gets $5, right? If he hits it, then he gets a chance for a second basket. So we're going to have another branch. He can either hit it again or miss it. So miss or hit. And this is for the second basket. Now the chance of hitting it again would be another 40%. Missing would be 60%. And so the possible outcomes, 0 baskets, 1 basket, or 2 baskets. Hitting 2 baskets, that's a hit and a hit. And he gets $25 if he does that. That's going to be 0.4 times 0.4 for a total of 0.16. The other option is a hit and a miss. If he does that, he gets $15. And so that would be 0.4 times 0.6. And so that's going to be 0.24. And then if he misses the first basket, he gets $5. And the probability of that is just 0.6. Now, it says, how many times a year do you expect Dale to get $5, $15, and $25? And just remember that there's 52 weeks in a year. So this is where our expected value from the other day comes in. For $5, our expected value, okay? Expected value, well, we know that the probability of just getting $5 is 60%, right? So 60% or 0.6 of 52 weeks is going to be equal to 31.2. So this means that there are 31.2 weeks out of the year where he's going to get only $5. Okay, so about 31 weeks. For $15, our expected value, we know that the probability of getting $15 is 24%. So we are going to do 0.24 times 52, which is equal to 12.48. So about 12 weeks out of the year. And then for $25, our expected value is going to be, we know that $25 is 16% of the time. So we're going to say 0.16 times 52, which is equal to 8.32 weeks, which is about 8 weeks out of the year. And then number 3 says, how much allowance should Dale expect to receive in a year? Well, if we have 31 weeks of $5, 12 weeks of $15, and 8 weeks of $25, we can say 5 times 31 plus 15 times 12 plus 25 times 8. That's going to give us a total of $535 in a year. And then number 4 says, should Dale's father accept the deal and justify your reasoning? So based on this model, he should expect to pay his son $535. On the old model, remember on the old model before this whole system Dale came up with, he was just getting only $15 a week, right? So on the old model, I'm going to write old model, he was getting paid $15 a week for 52 weeks. On that model, he was making $780 a year. And on the new model, we're projecting his dad to pay him about $535 a year. So based on this, we should say yes, his dad should take on this new model. In our reasoning, we can just say yes, his father should take the new deal. This would save him $245. And we got that just by doing this minus this. Now it tells us Dale practiced shooting baskets all year. It says he can now make baskets 60% of the time instead of just the 40%. Dale offers his father the same deal. And it says, what is the probability of Dale making 0 baskets, 1 basket, and 2 baskets? So we're doing the same thing again, only we're doing it with 60% instead of 40%. So we have, for our first shot, we have a hit or a miss. Hit is 60%, miss is 40. If he misses the first one, you just stop there. So the bottom branch stops. The top one, again, is going to have a hit or a miss. So we're going to have hit, miss, 60%, 40%. And the outcomes, if he hits 2 of them, that's $25. And so that's 0.6 times 0.6, which is 0.36. A hit and a miss, that's $15. That's 0.6 times 0.4, which is 0.24. And then a miss is just $5, which is 0.4. So it's asking us, how much money do you expect Dale to receive in a year? So again, we're going to be doing the same thing as before. We're just going to be looking at our expected value for each of the total possible outcomes right here. So we've got $5 expected value. That's going to be 0.4 times 52 weeks in a year. Okay, so 0.4 times 52 is 20.8. So we're going to have about 21 weeks out of the year where he gets only paid $5. For $15, we're going to have 0.24 times 52, which is 12.48, which is about 12 weeks out of the year. And then for $25, our expected value is 0.36 times 52, which is 18.72. So we're going to have about 19 weeks where he's going to be paid $25. But now Dale's younger brother, Brennan, wants his father to offer him the same deal. Brennan can make a basket 20% of the time. And it says, how many times do you expect Brennan to receive $5, $15, and $25? And also, what would Brennan's yearly allowance be under these conditions? So, the probability of 0 baskets. Okay? So that would be if he just misses the first one. It would just be 0.8. Because if he makes it 20% of the time, that means he misses it 80% of the time. So the probability of 0 baskets is 0.8. The probability of 1 basket is, well, that is a make and a miss. So we're going to have 0.16. And the probability of 2 baskets, that is 0.2 times 0.2, which is 0.04. So for $5, the number of weeks he's going to get $5 is 0.08, or excuse me, 0.8 times 52, which is going to be 41.6, or about 42 weeks. Probability of $15 is 0.16 times 52, which is 8.32, or 8 weeks out of the year. And the probability of $25 is 0.04 times 52, or 2.08, or about 2 weeks out of the year. So his total, because remember, it asked us to find the total amount of money that his dad would be paying him. The total amount of money is going to be $5 for 42 weeks, plus $15 for 8 weeks, plus $25 for 2 weeks, which is going to give you a total of $380 per year. And then number 8, it asks us, you have now looked at Dale's situation with a 40% shooting percentage and Brennan's with a 20% to determine what percent of the time they are each likely to receive $5, $15, and $25 in allowance. Now we need to make a table and a graph that show the relationship between the shooting percentages and the amount of allowance. So we looked at 20% shooting percentage, 40%, and 60%. And we said that for $5, it was 80% of the time, 60% of the time, and 40% of the time. For 15, it was 16, 24, and 24. For $25, it was 4%, 16%, and 36%. So the average amount of money that they are going to make is going to be, let me write my money symbols, $7.40, $10.60, and $14.60. And so if we were going to make a graph like this, right, Well, here is 0, and then I've got 20, 40, 60, 80, and then so on. So this is our percentage. And then over here, we're going to have average allowance per week. And so we're going to have $0, $5, $10, $15, $20, and so on. And so anytime they make 0%, it's just going to be $5, because if they make 0 baskets, they're automatically guaranteed $5, right? Now, for 40%, okay, 40% was about, or let's go to 20%. 20% was $7.40. So that's about right here. 40% was $10.60, so that's about right. Let me correct my 20% value. My 20% value was about right here. My 40% value was 10, we said $10.60, so it's going to be about right here. And then my 60% value was $14.60, so that's about right here. And so we can see this growth happening all the way up. And now number 9 says Brennan's ability to make a basket improved to 30%. Using your graph, what average weekly allowance should he expect? What is the actual average amount Brennan should expect? So if we look at our graph, and Brennan was making 30% of his baskets. Let me get my laser. We got 30% right here. We should expect him to make about, it's about right there, so we'd guess about $8 or $9. So we should expect him to make around $8 to $9. Now, if we wanted to get exact, what we could do, so the actual is going to be, well, he can make, if he makes 0 baskets, okay, since his shooting ability to hit, his ability to hit the basket is 30%. That means missing is 70% or 0.7, right? So if he was making just $5, that means he missed the first shot, so it would be 0.7. For $15, well, that's a hit and a miss, okay? So that would be 0.3 times 0.7. And then for $25, that would be a hit, and a hit. So I'm going to simplify this. It would be 5 times 0.7 plus 15 times 0.21 plus 25 times 0.09. So the final actual value, if you multiply all of this out, is going to be $8.90. And now it says, if Dale wants to earn an average weekly allowance of $15, what percent of baskets must he make? So if we go back to our graph, $15, if he wants to make $15 a week, he needs to be making about, it's a little past 60%, so I'm going to say about 63%. And then number 11, Dale's father figured out that he had been giving Dale $20 per week for his allowance. What percentage of his baskets is Dale making? So if we go back to our graph again, 20%, or excuse me, $20 a week, what percent does he need to make? So he needs to make about 80%. If we look down at our graph, 80% and 20% line up right here. So we can say about 80% of the time. So he is making a basket about 80% of the time.